Hi guys, welcome to Learn Electronics Repair. I just wanted to chat today about MOSFETs, and particularly in VRMs, but this is general for MOSFETs and many applications, and about how we can test them in circuit. This came about from this retro motherboard I had on a previous video that had short circuit low side MOSFETs, and I've taken the low side MOSFETs off. These are the high side MOSFETs, and somebody said they were probably faulty as well and I hadn't tested them. So I'm going to show you how to test them in circuit, and this applies to motherboards and graphics cards and anything else for that matter where we find MOSFETs, but there is a particular thing we need to consider, so we can't always test them in circuit by this method. And the main reason why we can't test them by this method is if there's a low resistance load across the MOSFET drain to source. With a VRM, if there is a low resistance, it's going to be something like the CPU or a GPU, and it will always be across the low side MOSFET. So from the low side MOSFET drain to the source, the low side source being connected to ground, that's why it's called a low side MOSFET, there is sometimes a load, and as I say, it's normally a CPU or a GPU. But if the load is fairly low, even RAM, which is a few hundred ohms, you can't test them by this method. But normally we have faulty high side MOSFETs, usually, okay? So no method's perfect, but this is still a very useful one to know, so let's crack on. So to do this, I'm going to use two multimeters. This multimeter, I'm going to put into diode mode. So on this, we press the button a couple of times, I'm in diode mode. I'm going to use this to apply voltage to the gate of the MOSFET. When this is in diode mode, it will provide about 1.5 milliamps. It's a constant current source. It will not go above 1.5. The voltage it generates is about 4 volts, roughly speaking, 3.5 or 4 volts. And that's enough to turn most MOSFETs on. So this is injecting current or applying voltage, whichever way you like to think of it. This is the grey and red one, so you'll know which one I'm using during test. The other multimeter has the common terminal, which is connected to both, and this is going to measure the resistance across the drain to source. I'm testing N-channel MOSFETs, so with an N-channel, the drain is positive, the source is negative, and I need to apply a positive voltage to switch the gate on. That's positive with relation to the source. With P-channel, you have to reverse this and have a common positive terminal and apply a negative voltage with respect to the drain. But I'm just going to do the N-channel. Those are the most common by far. So just bear in mind you can do this with P-channel as well. These are the high side MOSFETs. I've removed the low side on this board, but we can also do this when the MOSFETs are in place and the components I'm going to show you. But with this one, we'll connect the positive to the drain. This goes to 12 volts, by the way. You can see on the fluke meter there, it's reading the short down to 12 volts. So that is your 12 volts. This is the drain. That is ground. And I can now actually turn both these MOSFETs on without moving those leads because they're in parallel. So if I apply a positive voltage here, look, you'll see on the the little meter 1.9 volts, that's the voltage I'm applying to turn that MOSFET on. And on the fluke, you'll see the reading goes down to 160 odd ohms. So I'm not actually applying enough voltage to fully turn the MOSFET on, but you can see that the MOSFET does switch on. And that's a very good indication it's a good MOSFET. Because they're in parallel, I can also apply voltage to this gate. I'm now switching this MOSFET on, but the drains are connected together and the sources are connected together. Okay, And we can do the same on this phase. So again, positive to the drain, ground to the source, and then apply voltage to the gate. And you see, it's switched on, yeah, 13.2 ohms. This one, 13.2. Let's go back to these. Okay. These are not turning on anywhere near as fully as those. Because of that, I suspect these may be actually defective. Okay. There's enough suspicion for me to take those out and test them compared to these. Okay, 13 behaving quite differently. In this case, I have the inductors out, so the two phases are not connected together, okay? But if you're applying a voltage to the gate and measuring it across a MOSFET, only that one switches on, the one where you apply a gate. So again, you could read that in circuit. So this one tells me these are almost certainly good. These pair may actually be defective. Certainly, if I was undertaking a repair, which I will be on this, I'll replace them. In fact, I'm replacing them, I'll replace all of them. So that's how we can test them. Let's look at a few boards where components have not been removed. So on this one, actually, the capacitors have been taken off, but they will not affect this reading, to be quite honest. So here we have high side and low side MOSFETs. When there's three, you can pretty much always say the pair in parallel will be low side. And we can test that, so we can just measure these two on the fluke. You see they are connected to each other. Okay, they are low side MOSFETs. But if you really want to know the low side, the source, which is always this pin on this type of MOSFET, you can look up a data sheet for yours. The source will go to ground. So if we measure to ground, get a good ground, yeah. So the source of these ones are going to ground, they're in parallel. Okay, so we know these are low side. That means the drain of these two will go to the source of the high side. So these two are connected together. And that goes to the high side, which is the source of this one. Okay, so the junction of the source of the high side and the drain of the low side, that is your V-core to the GPU, to the processor, whatever. This board has the processor removed, okay? That means the other drain here must be the supply voltage. In this case, it goes to 12 volts. If I find the right pins, there, okay? So let's test these MOSFETs by trying to switch them on. High side first, so we'll go on to the drain, positive, source negative. Okay, this is where you need three hands. I haven't found another way. You may get a little clip to hold it in place or something like that. Maybe easier, but we'll go this way. You see I have a little bit of a reading on the NANG, and now I'm going to apply voltage to the gate. And that's switched on, and you can see on the fluke 6.9. And I can actually keep those there and switch all the other ones on as well. 6.9. Third one. Just get a good connection. .8. Okay, so they all read the same. So that's the high sides, and we know they're working. Now the low sides. So positive to the drain, negative to the source, in which case positive to the drain, negative to the source, which in this case is ground. So I'll just effectively stick my probe there. That's ground. Now I don't need three hands, and I can test them. Okay. So switch this one on. There you see it, 10K it's reading, okay. This one, about the same, about the same, about the same. So they all read the same. That basically tells us they're okay. There's the two in the middle. I forgot to test those ones, so we can also do it. Doesn't matter which of the drains I go to. About the same. Yeah. Same. Same. So we've tested all those. We know they're good MOSFETs. Here's a third motherboard. Now this one has all the capacitors in place. It has the processor fitted, okay? So we'll do the same with this one. We can see where the MOSFETs are. 1, 2, 3, 4, 5, 6 on this one. This looks like it has one high side and one low side per pair. Again, they're quite easy to figure out which are which. So we're looking for the drain of one connecting to the source of the other. So my guess is that this is probably the low side drain and this is probably the high side. Yep, they're connecting together on the fluke, you can see. So that tab, that is VCore. This tab then must be the 12 volts coming in. Trying to find where it is on this board so you guys can see. Okay, so that'll go to here somewhere. Yeah, that pin. So high side, low side. And we can do exactly the same. We apply voltage to the drain. I'm going to go onto the source of a different one just because it's easier for me to hold the probes in place. Okay, and we can try and switch them on. Yeah, 5.9. 5.9. If the one around the corner under this hand is on the same phase, that will also switch on. Yeah, 5.2. So we can test the high side. But because we have a load on this, this is the processor. And we can check that. If we connect from the drain, VCore, to ground, the load is about 19 ohms. That's the processor. I can prove that simply by taking the processor out. Okay, trying again. It's now climbing up higher. Okay, there is still a load, that'll be the north bridge, but it is higher. So with this one, if we try to test the low side MOSFETs, this is where this method will fail because we have too low a load across the MOSFET to test it this way. We can prove that. So connect to ground this time. Connect to the low side MOSFET, and this is where we're going to read about 20 ohms, yeah, and try and turn the MOSFET on. And it doesn't really change, yeah, you can see. You might say it has been affected. You can see we have about 1.7, 1.8 volts. That's the turn on voltage. And you know what, guys? I've actually managed to get this one to turn on. Okay. The resistance will gradually rise up as it discharges. In fact, we can just go, yeah. It's holding a charge in the gate. Back to 19 or 20 ohms, that's the resistance of the load. Try again. Can we get it to switch on? Yeah, look, it's switching on. Okay, guys, so I've now disproved what I said. I thought we wouldn't be able to see that, but we can clearly see it. Okay. So, yep, in this case, I can actually test the low side too. This won't work on a GPU where the load is like 1 ohm or something. It's too low. So I can try the other one. This is the other one. I think this is probably the gate. Yeah, see it going down. Okay. This meter has gone asleep. Okay, went to sleep. Happens, guys, yeah. So I'm actually testing low side as well on this one. Leave this on ground. We have this third pair over here. This is where the load is, about 20 ohms. We'll try and switch it on. There it goes, okay. Take the voltage off, it'll come back up again. So this is actually working better than I thought. Let's try it on the RAM VRM. So that's down here. We can see two MOSFETs again. We can easily figure out what is what. So the drain of one will go to the source of the other. So we have this drain and this source. Are they connected together? Yes. If you look at the other drain and the other source, they are not connected together. Okay, just to prove the point. So these two are connected together, drain source. So that is the supply voltage to the RAM. One of these is the high side, that would be the one with the tab. So that would be going to the 5 or 12. And the source of this one will go to ground. So to test the high side, same thing. Positive to the drain. Negative I can put on the drain of this, which is connected to the source anyway. So on the two tabs, and we should see basically open. It's very high, mega ohms. We'll try and switch it on. Let's get a good connection. There we have it, 21 ohms, off, open again. So high side is good. Now the low side, positive to the drain. This is your RAM supply. Negative can go to ground again. In this case, I'm on the low side, so it's easy for me just to stick this into a ground rather than using three hands as I need. Okay, so let's see, just make sure I have a good connection to ground. Yeah, I do. Right, so resistance from the drain. This should be the resistance of the RAM. Yeah, about 200 ohms. Okay, that's the RAM. Because there's one strip of RAM in. Try and switch this on. And there it goes, yeah. It's going down. Okay, off. Coming back up again. So we know that's another good MOSFET. You might also be able to test these sort of devices, but it kind of depends this. If you can look up the data sheet and you can find the drain of the high side, that's easy enough anyway, because you can just probe what's going to 12 volts. You can find the pins which go to the core voltage, that is the coil, so you can find that, and you can find where it goes to ground. You can find that, and if you can find where the gate is. But some of these may not give you a direct access to the gate. It depends on the data sheet. But if it does, and it may well give you access to the high side gate and the low side gate, you can test them in the same way. But bear in mind, when you have a very low resistance load like this, the load will read less than 1 ohm anyway. I think this one is actually a short circuit one. It's a scrap board. But certainly the high side MOSFET built into these, you can test in the same way I've just shown you. So this is a very, very handy technique. If you were not familiar with it, well, you are now. It's very simple to do. 2 multimeters, and let's face it, we should all have more than one multimeter. We know that. And you can quite happily go around circuit boards and test MOSFETs, and not just in VRMs either, MOSFETs and power supplies and other circuitry. If you want to know, is it working without removing it, now you know how to test that, apart from the one thing about very low resistance loads. I hope you guys found that useful. I did demonstrate this on the All You Need to Know About Diode Mode video, but I know not everybody watched that, so for the ones of you who didn't, you've seen it now. Stick that little technique in your tool bag and it will serve you very well. Okay, just a short one then, and I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.